Question number 1. Block A of weight 4 Newton is kept on another block B of weight 12 Newton, which rests on the floor F as shown in the figure. A is connected to the wall by an inextensible light rod. If the coefficient of static friction between A and B and B and F are the same and is equal 1/4, the minimum force P required to drag B to the left is. There are two objects. A and B. A is connected to the wall by using a rod. We have to find the minimum force required to drag B to the left. We have to find minimum value of P to move B to the left hand side. Then I will mark frictional force. Block A, weight of block A is 4 Newton. 4 Newton. Therefore, reaction from this point also 4 Newton. We can consider vertical equilibrium of A. And weight of B is 12 Newton. Weight of B is 12 Newton. Then reaction from this point is 16 Newton because of the reaction is equal to the sum of all forces, sum of 4 Newton and 12 Newton. It is acting on this point. Then when we are trying to move B to left hand side, there is a frictional force to this side from the bottom surface. I will consider it as F1, and there is another force, frictional force F2. Now we have to mark forces on B. Now we can get that minimum force required to move P should be equal to F1 and sum of F1 and F2. It is the minimum force. If the P force is greater than sum of these two forces, this object B should move to the left hand side. Then I will substitute values. We can substitute F1 is mu1 R1 plus F2 is mu2 R2. Mu is the frictional coefficient. Then they have given frictional coefficient between static friction, coefficient of static friction between A and B and F are same and it is equal to 1/4. Then mu1 is 1/4. Reaction. F1 is force from bottom surface. We have to consider reaction from bottom surface 60 plus mu2 1/4. Reaction from upper surface is 4. Then we can simplify. 4 plus 1, 5 Newton. It is the minimum force required to move the object B. Then answer is 5 for the question number 1. Then question number 2. A trolley A is on horizontal track B is a wooden block of mass M. If the coefficient of static friction between trolley and the block is mu, the minimum acceleration of the trolley that is required to prevent the block from sliding downhill. There is a trolley like this, and the weight is touching the front surface of the trolley. Then moving this system to the right hand side with an acceleration, simple A. A is the acceleration. There is a reaction on B from this point. We can use F equals MA to find the reaction. I will use F equals MA for the block B. F is the horizontal reaction. I have to use in this direction. F is the horizontal reaction on B. It is R. Mass of B, I will consider it as M. It is not given in question. Into acceleration. Then reaction is MA. Now, for the equilibrium of B, weight of B, mg, should be equal and opposite to the frictional force on B. We can write frictional force equals mg. Upward frictional force should be equal to downward weight. Now we can substitute frictional force mu r equals mg. They have given coefficient of static friction is mu. We have to substitute r as ma. Mu ma equals mg. Now we can cancel out m and m. We have to subject a. A equals g over mu. G over mu. It is the smallest acceleration to avoid moving block B in downward direction. Then acceleration is g over mu. It should be to the right. Then answer is 1 for the question number 2. Question number 3. The box is dropped at time t equals 0 vertically on a conveyor belt, moving at constant speed at the horizontal direction as shown in the figure. If the box attains the velocity of belt at time, to which of the following curves best represent the variation of magnitude of frictional force exerted on the box by belt with time t? The initial horizontal velocity of the box is 0. It should get the speed of belt. Therefore, there should be a frictional force on the box and it should be 0 after getting the corresponding velocity, after getting the velocity of belt. Then answer should be 4 for the question number 3. Then question number 4. A block rests on an inclined plane whose angle of inclination theta to the horizontal can be varied. Which of the following graph of variation of frictional force between the block and the plane will with theta? We considering an object on an inclined plane. Initially, this object is at rest, therefore, initially we have to consider that theta is 0. It means this plane is horizontal. If this plane is horizontal, there is no vertical movement. There is no movement along the inclined plane. It is not trying to move, therefore frictional force should be 0. When increasing this angle, we know that weight is mg and this angle is theta. Therefore, weight component in this direction, mg cos theta. It is equal mg sin theta. It is equal and opposite to the frictional force. Now, when increasing theta, we know that sin theta also increases. Therefore, frictional force should be increased with time. When moving this object, its acceleration is increasing with time. Therefore, we can consider that frictional force increasing like this, and after starting to move this object, the acceleration is increasing with angle. When angle is increasing, acceleration of object is increasing. Initial acceleration is corresponding to this angle. Therefore, acceleration increasing, resultant force should decrease. Then frictional force is decreasing with time. Then answer is 5 for the question number 4. Question number 5. As shown in figure A, force P is applied on an object of mass 2 kg lying on the horizontal surface. The coefficient of kinetic friction between the two surfaces is 0.5. If the object moves with uniform velocity, the normal force R acting on the body. You have to get normal force R acting on the body. The given push is like this. It is 45 degrees with the horizontal plane. Weight mg, reaction R. As shown in the figure, force P is applied on an object of mass 2 kg lying on horizontal surface. Coefficient of kinetic friction between two surfaces 0.5. If the object moves with uniform velocity, they have given that object is moving with a uniform velocity. Therefore, there is no an external unbalanced force on the object. According to the Newton's first law, we know that there is no an external unbalanced force on the object if an object is moving with constant velocity. Then we can get horizontal component of P cos 45 should be equals to friction on object in opposite direction. It is not moving. We have to find the normal force on the object. It means reaction on the object. Then we can substitute P cos 45 equals F is mu R. Mu 0.5, reaction R. We have to find R. I will consider it as the first equation. Then we can consider vertical equilibrium. This is the horizontal equilibrium. And now I will consider the vertical equilibrium. In downward direction, there are two forces, P sin 45 and weight mg. It should sum of downward forces should be equal and opposite to the upward force, upward reaction. We know that sin 45 value and cos 45 value are equal to each other. Therefore, we can substitute 0.5 r to this place. Then 0.5 r plus mg equals r. Then I will bring 0.5 r to the right hand side. R minus 0.5 r, 0.5 r equals mg. Now we can substitute mass. Mass is 2 kilograms. Then mg 20 Newton. 20 Newton equals 0.5 r. Then finding r, we have to divide 20 by 0.5. 40 Newton. Then answer is 5 for the question number 5. Then question number 6. An object lies on a horizontal table. When the object is pulled by horizontal force F that increases uniformly from 0. The variation of frictional force F acting on the object is best represented by the graph. We have to remember the corresponding graph. When pull is increasing, we know that frictional force is increasing up to limiting frictional force, and when increasing pull after limiting frictional force, it is a constant value like this. We know that this part is static friction, this part is limiting friction, this point, and this part is kinetic friction. Then we can get C is the correct answer for question number 6. Then question number 7. Which of the following figures shows the direction of frictional forces acting on two tires of bicycle when it is paddled by a rider on a surface with friction? You know that when paddling, we are rotating rear wheel of the bicycle. Then to rotate rear wheel, we have to give, when rotating rear wheel, we have to give a force on earth by rear wheel to this side, and frictional force on rear wheel is opposite to this force, equal and opposite to this force. But when considering front wheel, it is rotating without using the given force. It is rotating due to friction. Friction is opposite to the movement of bike on front wheel. Then you can get 2 is the correct answer for question number 7. Question number 8. A box of mass 5 kg is placed on a horizontal surface. The coefficient of static friction between the box and surface is 0.3. If the horizontal force of 10 Newton is applied to the box, the magnitude of frictional force acting on the box will be. I will consider the maximum force on the box, maximum frictional force. I will consider it as F max. Maximum frictional force is, we can calculate maximum frictional force by using mu r. Mu 0.3, weight, mass is 5 kilograms, then weight is 50. 3 into 0, 0, 3 into 5, 15, we have to separate one decimal place. It is the maximum frictional force. Now we are given 10 Newton pull on the object. It is less than maximum frictional force. Therefore, the object will be at rest by giving 10 Newton frictional force, equal and opposite force on the object. Then answer is 4 for the question number 7. If the given force, this force is greater than frictional force, it will move along the horizontal axis, and then we have to consider acceleration of the system. We have to use F equals ma. But now in this condition, the given force is less than to the maximum frictional force. Therefore, object is not moving. It means given force is equal and opposite to the frictional force. Question number 9. A box placed on the floor of an elevator. If the magnitude of minimum force required to side the box on the floor, when the elevator is stationary, accelerating upward and accelerating downwards are F1, F2 and F3. You have to compare F1, F2 and F3. This one is question number 8. Now 9. We have to compare stationary accelerating upward and accelerating downward condition. When accelerating upward direction, I will consider an object which is in an elevator. Weight mg, reaction r. When accelerating upward direction, we have to use F equals ma to the upward direction. Resultant force is r minus mg. R is the upward force, mg is the downward force, ma. Then r equals mg plus ma. Now we have to consider that effective reaction is increasing. It is greater than mg. Effective reaction for upward acceleration is greater than mg. Therefore, frictional force is greater than stationary condition. F2 is greater than F1. F2 is greater than F1. And for the third situation, we can get by using this method, reaction is less than the reaction when the elevator is not moving. Therefore, frictional force for third condition, F3, should be less than stationary condition. F2 less than F1 less than F3. Then answer should be 1 for the question number 9. In question number 10, the box is placed on a horizontal surface and a horizontal force F is applied on the box. Variation of magnitude of F with time is shown in the graph. Which of the following graphs shows the possible variation of magnitude of frictional force acting on the box with time? If the given maximum force is less than limiting frictional force, graph will be like A. And if the given maximum force is greater than limiting frictional force, graph will be like C. Then only A and C are correct. Answer is 5 for the question number 10.